It's going to be called solving quadratics. But so basically what you have to do here is f of -4, right? Use this one. H of -3, because it's h, you have to use this one. So I will do one of them. F of -4, because this is already there. It's really just -3, -4 minus 5 squared plus 5.25, right? And I'm inserting this -4 into the x here. And what happens there, it says it's -3. This adds up to -9. We square that plus 5.25. And so this is -3 times 81 positive plus 5.25. This is 3 times 8 is 24. -24, 243 plus 5.25. And then we can just do one last. This is -237.75. So basically, you found a point on the curve, which is -4, -237.75, right? All right. I think that answers, I'm sure that's going to answer most of the questions that you have. So you're doing two, like when you're doing f of 0, you're actually doing two things at the same time. You're finding the y-intercept, and it happens to be another point that you're finding that is on the curve. Every time you do one of these, that's essentially what you're doing. Okay. I'll pause. Don't mix it up with my notes. Okay. Today, this is basically the last thing that we need to cover that is brand new. And I'm going to call this solving quadratic equations. And by the way, as you're coming through here, I'm going to give you the booklet with all the handouts for the next unit. So if I don't, please remind me. Okay, so when you are asked to solve a quadratic, you need to determine find the x-intercepts. Intercept or intercepts, okay? Note, x-intercept or intercepts is the same thing as zeros, is the same thing as roots. They all mean the same thing. Solutions, okay? So sometimes they will say find all the solutions to the problem, all the roots, zeros, x-intercepts. That all means the same thing, okay? So don't let that throw you off. Should have probably mentioned it before that the other AC we did, right? But I told you what that was. in all cases, y is equal to 0. Remember that, because that's really the definition of x-intercept, right? When does it hit the x-axis? When y is equal to 0. Two methods of solving a quadratic. First option is using the quadratic formula. And sometimes I'll refer to it as the QF. And by graphing two options here. So really you have three, but we tend to break it down into using the quadratic formula or solving by graphing, and that's using the calculator. And so we're going to start with the quadratic formula. Given y is ax squared plus bx plus c, this is in standard form, we can find the x-intercepts or solve the quadratic by using this formula, and this needs to be on your formula sheet, and it needs to be written down correctly. I will put brackets around every single letter that is here, because if not, I notice a lot of students make mistakes. Yes, there is a plus and minus there. For now, just trust me. And I will put a bracket around this B here, a bracket around that A, bracket around C, meaning you're going to have to substitute it into that slot. And it's not done yet, but I'm going to wait till you're there, because this is where the biggest mistake happens when I add the second part to it. So it's negative b plus or minus the root of b squared minus 4 times a times c. All of that, okay, you start right here. You make a long line. You underline the whole thing. Okay, the whole thing. Two times a. So, okay, so the line goes from here all the way to here. So 2a is dividing everything in the numerator, not just like a lot of students put the 2a under the root and then they mistakenly calculate that and only divide this little piece here, but it's really the 2a is dividing everything in the, so box this in. I'm gonna highlight the inside the root here. You don't have to, but that has a name. That the part that's inside the root has a name. So b squared minus 4 times a times c is called the discriminant. Okay. If b squared minus 4ac is, so if you just do that inside part there and you realize that it is negative, right? That means that you'll have no x-intercepts. Right? You can't take the root of a negative, right? So that's another way of saying it. If it is 0, you have one x-intercept. If it is positive, two x-intercepts. So if you end up with a negative, you can't just stop it. You have to tell me the discriminant is negative, therefore there are no x-intercepts. You don't have to justify the other two, but this one needs to be justified. Like if you can't do it, you have to tell me you can't do it because there are no x-intercepts. And here is an example. Notice that right now you have something new equals to 0. Normally we have y is equal to, and then you have the equation, right? But why is this 0 here? Let me take you back to the top. If you're trying to find the x-intercepts, in all cases y is equal to 0, okay? So we technically replace the y with equal to 0. So by using the quadratic formula, we consider this a, b, and c. So this technically should remind you of the standard form of the quadratic. Okay, so a in this case is equal to 3, b in this case, and it's positive, right? The sign goes with it. B is equal to 3, and c is equal to negative 3. And now we use our formula to figure out the x-intercepts. So you will not be able to do this with, you can use your calculator, like graph it and actually find it, but if I ask you to use the quadratic formula, you're going to have to use it. So watch, I'm going to use the formula up there that I gave you. It says negative b. B is 3, right? So I'm just going to plug it in like that. Plus or minus. We will take care of this later, okay? Just for now, just write it down like that, plus or minus. Square root of, it says b squared minus 4 times a times c, which is negative 3. Like that. All of that divided by 2 times a. There's a lot of 3's here, and I know that we'll do more examples where those numbers are actually different. Those numbers could be decimals, it could be whole numbers, it doesn't matter. We have a calculator to help us, right? So let's clean this up a little bit. This is how I do it. We can get rid of the brackets here because there's no negative inside. So it's just like that. Plus or minus root of. Let's figure out what this inside part is here, the discriminant. So you can actually just take your calculator and you just go 3 squared if you want, right? Minus 4 times 3 times negative 3. If you don't want to use times and you want to use the brackets instead, just like I have done, go for it. But remember, this negative here follows me. And this minus and that negative will actually turn this whole thing positive. So you hit equal and you get 45. Positive 45, very important for us here. That's 45 over 2 times 3, which is just 6. And this is where you branch off at this point. You know that plus or minus there? It's using the symmetry of the parabola, right? It's almost, you're almost centered in the middle, and right, you're centered in the middle, and if you go minus, you're going to find the one that's on the left side of the vertex. If you go plus, you're going to find the one that's on the right side of the vertex, right? So here I branch off to make this fit in here. I go up arrow like this, and you can go below it if you have room. Just keep going below, right? But the first x-intercept, we know that the inside, the discriminant is positive. So we know that a positive value will result in 2 x-intercepts. So the first x-intercept is negative 3 plus root of 45 divided by 6. And let's figure out what that is. So type this in with me on your calculator, okay? So you know how to do this, because I always assume you know, but I don't want to make assumptions. So square root is second x2, by the way. Second x2 calls the root. You go 45. Please hit enter at this point. Don't go divide it by 6, because it's gonna only divide the 45 if you go divide it by 6 right now. So I just hit enter, and then I take the answer and divide that by 6, and it's 0.618, which is 0.62. So it's 0.620 is the first x-intercept. You've just found it. So you have taken care of the positive, right, is up here. And then you're going to take care of the negative. I'm going to have to use a different highlighter for that one. So I'm going to come over here and find the second x-intercept, which is negative 3 minus. So everything will look the same, okay, between the two, except for one will have the minus and one will have the plus. And that's because you're using the symmetry of the parabola. So you go, I'm gonna go and maybe borrow the line up there. Just bring it down with me and just change the plus to a minus like that. Hit enter and then divide that answer by 6, and that is negative 1.62. So it's negative 1.620 is the other x-intercept. So you found them both using the quadratic formula. You're still with me? Yeah, it's not bad, right? What's gonna be a bit more challenging is I'm gonna mix them up a bit, so you do have to have some multiplication happening there. Just quickly with, if you wouldn't mind, I will do this. I will type in 3x squared plus 3x minus 3. Graph that. And there it is. Okay, so that is the curve here given by this equation. Oh my goodness, this is slow. Second try is 5. So I'm going to find the first one. And I don't know if you notice, right on the screen is negative 1.62 rounded. That's exactly what I got. If you go find the other one, you should get the same thing. That's 0.62, right? That's the first one I got. So it works, right? That's a way. This would be doing that graphically, by the way. But I will show you how to do that later on. Let's try another one. Huh. What if you have to clean up a little bit? So something like this. We need to rewrite. Bring everything over to one side. You choose. You want to bring everything over to the left or everything over to the right. But you have to have an equal to 0 on one side, okay, for this to work. I'm going to bring everything over to the left side. So everything here is going to change signs. So I have the 8x squared. This one comes over subtracting. You have the 5x on this side already. The negative 4x comes over adding. And the 7 is already there. And I'm left with 0 on the other side. 8x squared minus 3x squared, that is just 5x squared. This would be 9x, right? These two, and then 7 at the end, and that's equal to 0. We'll just highlight this, right? That the signs changed while coming over. And then you have A is equal to 5, B is equal to 9, C is equal to 7. And let's see if we can do this. That'd be negative 9, right? Plus or minus 9 squared minus 4 times A. The 4 is always there, okay? A is 5, C is 7. Over 2 times A. It's negative 9. Let's figure out what this is. You could do mental math, right? 9 squared is 81. 4 times 5 is 20. Times 7 is 140. Right? So you know already that this is going to be bigger than that. But go ahead and type that in. That gives you negative 59. So we have a problem, right? No x-intercepts. Comma, since the discriminant is less than 0. You can also say b squared minus 4ac is less than 0 if you want to put it that way. That's an alternative way of if you forget the name discriminant, just tell me that, right, this is less than 0, is negative, can't be done. And if you were to graph this, it would never cross the x-axis. It wouldn't. Okay. So you're done. If that happens, just gotta justify. Need to justify, okay? The other ones you justify by just calculating it, right? Solving by graphing. So there's the other method. You have two options. First option is rewrite equation into standard form. Then enter into y1 and find x-intercepts using TI-84. So this is basically how you've been doing things all along anyways. Like most of the time it was in standard form. The second option is what I prefer if I can graph, right? You have to enter left-hand side into y1, enter right-hand side of the equation into y2, only report the x values of the intersections. Answer is always stated as a number 0, right? Even though 0 is a number 2. But I think you get the point. That's the only tricky part here. Students forget they want to report the y values as well. So let me just try something quickly here. I'm just verifying something here before I make you copy it. I'll be right there. Just trying to make sure this works out. I think this will work out. on the new page. That's So we're going to combine. Solve the following using the quadratic formula and the graphing method. Okay. So if I give you this, 8x squared plus 5x plus 7 is equal to negative 3x squared minus 4x plus 18 . So when I ask you to solve by graphing method, we will type this into y1. The left-hand side of the equation goes into y1, and the right side of the equation goes into y2. Then you go second, trace 5 to find the intersections. And we'll go ahead and do that. So go ahead and, as soon as you wrote this down, type that into your y1 and your y2. Right? So it's essentially, in this case, it'll be two parabolas. It could be a parabola and a straight line. Okay, that's not out of the question. One of them will be a parabola, for sure. Sometimes both. And it's still graphing. Anyways, once you type that in, you should get, you have the one appearing up here, and hold it, like, look how slow this one is. This is why I have it, not you. So you see the second one, this is a zoom standard window. That's probably the way to go zoom standard, because you've probably worked with word problems. You have tens of thousands going every way, and that might be too much for these. So right now I just need to increase my window. I'm going to go Y max. I'm going to go 150 just to be safe. And what you're looking for is the intersection between the two. So there it is. They cross here and here. So finding those two, I know it sounds weird, but those two will be the solution to this system basically. So finding both of these is what you want to do. So I'm going to go second, trace 5, and then I'm going to find the first one here, and that is negative 1.49, and I'm going to write down the y value as well. but that will actually be incorrect if that's your final answer. And then I'm going to find the second one. That's that one there. And that is 0.67, 13.96. So that's the two instances where that happens. The roots would actually be negative 1.49, 0, 0.670, and you will see in a bit that that is true. This is using the graphing method where you just type in this into y1, this into y2, and then you find the intersections, but these are actually the roots. So make sure this is 0. So you don't have to report the y values of the intersections. I'm just showing you that that's what it actually shows on the calculator, but we change it to this. Okay, so you kind of have to do a soft cross it out softly, just like that. Okay, just so you can tell that that shouldn't be there. Using the quadratic formula, we need to rewrite in this case. So we'll bring everything over to the left. That's normally what I do. 8x squared plus 3x squared plus 5x. The 5x is already here. It looks very similar to the other one I gave you, right? Plus 7 minus 18, and that is equal to 0. And this gives you 11x squared plus 9x, and this will give you minus 11. All right. So I'm bringing everything over to one side. I combine my like terms. Got to be careful with the sign, right? And so now it's the way the first example that I gave you has it like this, right? We know based on what I just told you that there are two x-intercepts, right? And we know that they're negative 1.49 and 0.67. And this should be the exact same. This should give you the exact same result. So A is equal to 11, B is equal to 9, C is equal to 11. Negative 11, sorry. Very important to not drop the negatives. They can make everything be off for getting the negatives. And I'm going to use that formula. Negative B plus or minus. And when you do the homework, you're going to encounter different scenarios. B squared minus 4 times A times C. All of that divided by 2 times A. And then we have negative 9 plus or minus root of, and this should just give you one number. Okay, we know it's going to be a positive because we had 2. So it's 81 minus 4 times 11 times negative 11. That gives you 565. Make sure you know how to do that, and divide it by 22, And to save paper, I'm going to go up like this. And I'm going to find the first one, which is -9 plus root of 565 divided by 22. So we're going to go -9 plus root of 565, hit enter, then divided by 22. And that's 0.67, which is exactly what we have up there. You can go look quickly. Sorry, I don't know why I put this equal sign there. I just went from here to here, and then I like to answer it like that. And then x2 is -9 minus root of 565 divided by 22. We're expecting -1.49 according to the answer we had previously. I'm just going to copy what I did earlier. Go minus, divide that by 22. That's -1.49. Let's redo the point that you found. That matches. Note, you could have solved graphically. You could have also solved graphically after rewriting the original. And this, I'm going to show you why this is true. Because I told you that you could solve graphically by rewriting it, or by just leaving it the way it is and type the left-hand side into y1, right-hand side into y2, correct? It technically is still the same, because if this is y1 and this is y2, isn't that what we always do to find the x-intercept anyways? Let y2 equal to 0, right? That's what we're doing anyways. So it will still give you the same. You go second, trace 5, and let's just not, I don't think we need to do this. I think you believe me, but at this point. But in this case, you can actually state like it's going to be 0 anyways, so you can state your y, the y value as being 0. So there are two ways of solving graphically. I personally wouldn't rewrite because there's a lot of chances of making a mistake if you rewrite. So if it, and I will tell you this, most likely, it is very likely that I will give you something that's very ugly where you're not going to feel like rewriting it anyways. So almost like forcing you to do this, and where you just have to watch out for this part, right? That make sure it's 0. Sorry, if you're at home still writing down, go ahead. Go ahead. I'll give you some to try right now. I'll write them down and see how you do after the lesson and it's still warm. Okay, it's still fresh. And by using the quadratic formula. Solve the following using a graphing method and by using the quadratic formula. Let me make this a little different. Sorry. We're going to bring the x out here. It's going to be 2x plus 3 like that. And it's going to be 5x squared plus 7x minus 4. Is 4x, x plus 3. And you might ask yourself, what happens if two curves never touch? That also means that there are no x-intercepts. So give those a try.